it's really not. So we are going to be doing, we are going to be Target C day 1, which is the next page of notes. So we are going to be on page 14. So take a second to get on page 14, will you? And I'll get there too. We are just doing page 14 today. I do think we should have time to start the Go Formative. So I'm going to teach today, and then tomorrow will be a work day. Tomorrow's work day should not be backbreaking by any means. Like I said, today really is a review day. You do know how to do these things. I'm reteaching you how to do FOIL and all that stuff. I didn't want to get into the new stuff just because Monday's an asynchronous day, so I will start fresh at that on Tuesday. So we're going to end this week kind of easy. So I will take you down memory lane, but I don't anticipate it's taking the whole period. So let's just do what we know. So today, to start us off with Target C day 1, we are going to be learning about adding, subtracting, multiplying, and then dividing polynomials. You have already learned how to add and subtract and multiply polynomials, but I will take you back down memory lane and remind you how to add polynomials. When we add polynomials, we only can do math with their like terms. So when we add polynomials, we only do the like terms. And I'll show you what that means. But we only add the like terms. Only add our like terms. And so when we add polynomials, we add their coefficients and we don't change the exponent. So it's worth mentioning, we add their coefficients. Oops. Add coefficients. And don't change the exponents. That's a big deal. Alrighty. So when we do this, so we have an example here. If I am adding two polynomials, I am going to add their coefficients. Their coefficients are the number in front of the letter, and I don't change their exponents. So in this example, I only add the like terms. So what I mean by like terms is if I see something m squared, I can only add it to something else m squared. So this, I cannot take 4m squared and add it to negative m because they are not like terms. They don't look exactly the same. But I can take 4m squared and add it to 1m squared. So remember, if something does not have a coefficient, it has a coefficient of 1. So if something doesn't have a coefficient, it has a coefficient of 1. So I can add these like terms. I add their coefficients. So 4 plus 1, which is equal to 5. And then m squared. I'm going to erase that m. So I add their coefficients and I do not touch their exponents. So it is not 5m to the 4th power. Do not add their exponents. It's 5m squared. How many total m squareds do you have? Well, you have 4 and I'm adding 1 to them. So I have 5m squareds. Alrighty. I like to cross things out. I'm a big visual person, so I like to cross them out. I took care of those. I do not have a like term for negative m. There's nothing else that's just 1m that stands alone that I can compare it to. So I have, that's going to stay. And then I also have any number that stands by itself as a like term. So 5 plus 6. 5 plus 6 is equal to 11. So putting this all together, I have 5m squared, right? This one goes first. Then I had that negative m, and then I had plus 11. So I just am cleaning this up by adding my like terms together. Any questions? What questions do you have? All right. Subtracting the polynomials is very similar. When we subtract polynomials, we need to distribute the negative. So subtracting polynomials, we are going to distribute the negative, and I'll show you what that looks like. Distribute the negative, and again, don't touch the exponents. So I am taking 7y to the 4th power minus 2y squared minus 5y to the 4th power minus 5y squared plus 8. This is subtraction, but we're going to call this a negative. So I'm going to distribute the negative to everything that comes after it. So what I'm going to do is I'm going to rewrite the pair of parentheses that comes first. I'm going to rewrite everything that came before the negative. So I'm going to rewrite 7y to the 4th power minus 2y squared. And then I distribute this negative. I distribute it to this thing, and to this thing. Remember, no negative stands alone, so I'm technically distributing a -1 and multiplying a -1 by each thing inside the pair of parentheses. Multiplying everything by a -1 is going to change their signs. So if I multiply -1 by a positive 5y to the 4th power, that's going to become a -5y to the 4th power. So I'm going to distribute the negative and rewrite. So I'm going to, distributing the negative just basically changes the signs. So I have a -5y to the 4th. This used to be a -5y to the 2nd power, but multiplied by a -1 is going to give me a positive, so plus 5y to the 2nd power. And then that was a positive 8, but now it's a positive 8 times a -1, which will give me a -8. Any questions on what I have right here? I rewrote what's in front of the negative. What's in front of the negative stays the same. I distributed the subtraction sign, which we called a negative, to each thing, and I rewrote it. And all it really did was change the signs of everything in the parentheses. Now all I'm going to do is combine my like terms. Now I'm just going to combine like terms. So I have 7y to the 4th power. In the chat, please, which one can I combine with 7y to the 4th power? Which one is its like term? What's its like term? 7y to the 4th power. Yes, -5y to the 4th power. Perfect. Thank you. So 7y to the 4th power minus 5y to the 4th power will just give me 2y to the 4th power. Right? 7 minus 5 is 2y to the 4th power. So we just work with their coefficients, keep the exponents the same. I like to cross things out. All right, then -2y squared has a like term with 5y squared. -2 plus 5, if you need to use your calculator, by all means, please do. -2 plus 5 is positive 3. So plus 3y squared. And then nothing goes with that -8, so it's just along for the ride. Okay. Any questions so far? Remember, you always keep the sign that comes in front. So that was a -5y to the 4th. That was a -8. Always keep the sign that was in front. Okay. Alrighty, and then the last thing I'm going to take you down for memory lane is multiplying polynomials. Multiplying polynomials we've already been doing throughout this unit so far, just pretty discreetly. But I will just use today's your day to just mess around with it. I told you the very first day of the unit, I showed you FOIL, the very first day, like January 4th. a whole month ago. And I showed you the box method. I told you the FOIL method is superior, so I'm going to keep using the FOIL method. But regardless, when we multiply polynomials, just a quick reminder, we are going to multiply their coefficients. So let me write that down. We multiply their coefficients. I'm going to shorten both of those words. Multiply their coefficients, and you add their exponents. We've been doing this subtly. Okay? So when I say multiply 4x squared times 6x, the very first thing I want you to remember, which you guys are pretty good at remembering this, is if a letter doesn't have an exponent attached to it, it has an exponent of 1. So now I'm ready to just multiply their coefficients. Again, the coefficients are the numbers in front of the variable. I have 4 times 6, which is 24. And then I have, so I'm going to rewrite it down here. I have 24x and then 2 plus 1, which is 3. So 24x to the third power. 2 plus 1 is 3. Multiply the coefficients, add the exponents. Okay, that's a simple one. Now, if I do something out here, you need to be careful with parentheses. If I have one thing outside a pair of parentheses, you need to distribute. Always. Forever. That's always what we do. All right. When you distribute, that means whatever's outside the parentheses needs to get multiplied by everything inside the parentheses. So the 2w needs to get multiplied by the 5w squared. And so I'm going to do plus, because I'm adding these things because the 2w is positive, and the 2w needs to get multiplied by the 6. All right. Reminder, this w has an exponent of 1, because now I'm going to clean it up. 2w to the first power times 5w squared looks complicated, but multiply the coefficients. 2 times 5 is 10. W, and then w to the first power times w to the second. 1 plus 2 is 3. All right. Plus, and then 2w times 6. Well, I'm going to multiply their coefficients together. 2 times 6 is 12. And then 6 doesn't have a w, but the w doesn't disappear, so we just add it back onto the end. 2w times 6 just gives me a total of 12 w's. All right, I'm not going to add these together. I can't clean that up any further. I can't make that 22w to the fourth because they are not like terms. Leave it like that. Those are not like terms. If, don't write this down because it's wrong, if this was 12w to the third power, you could clean that up and make that a total of 22w to the third powers, but this is just a w that stands alone and they just coexist together, but they are not like terms. Okay, questions there? Alrighty, then this one that I think is probably the most familiar with us is when you have, anytime you have a pair of more than one pair of parentheses, we are going to do handy dandy FOIL. If you know and remember the box method, you are more than welcome to use it. But I will not show you it. If you remember it, that's absolutely fine. I will show you FOIL. What I cannot stress enough for you is you need to show work. If you didn't show work for something like example 3, I can live with that. Anything for example 4, especially example 5 and 6, you must show work. If you take example 5 and you just come up with the answer, you will get not a single point. Alrighty, I know there's calculators out there that will do this work for you. There's no way you did this in your head, especially something like example 6 that's going to be a lengthy process. No way you did that in your head. Alrighty. So please, 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 when in doubt, show your work. Alrighty, but let's go ahead and do example 5. We are going to do the FOIL method. So FOIL means first, outer, inner, last. what it means in simpler terms is, sorry, all that stuff's going on. Everything in this pair of parentheses needs to get multiplied by everything in this pair of parentheses. And I like to keep my work organized by using arrows. So I just like to keep the first term needs to get multiplied by the first term in this parenthesis. And the first term needs to get multiplied by the last term in this pair of parentheses. Okay. Then the 4 needs to get multiplied by the first term in this pair of parentheses, and the 4 needs to get multiplied by the last term in that pair as well. Now, if I follow my arrows, then everything has been multiplied by each other. Everything in this pair has been multiplied by everything in this pair. Now, I'm just going to follow what my arrows say to do. So my first arrow said to take 2z and multiply it by 3z. So I'm going to take 2z, I'm going to write it all out, 2z times 3z. I'm going to just write it all out and I'll clean up at the end. Done. Then I'm going to add, you're always going to add in between these. Then I'm going to follow my second arrow. My second arrow said to take 2z and multiply it by -3. So plus 2z and multiply it by -3. Okay, so I multiplied, 2z has been multiplied by everything in the second pair of parentheses. Done. Now let's take 4 and multiply it by 3z. So plus 4 multiplied by 3z. And then let's take 4 and multiply it by -3. So plus 4 times -3. Alrighty. Questions so far? I know this, you've seen this before, but just in case I've lost some of you, I'd like for you to ask. All right, now we just have to clean this up. Again, you need to show this work. Maybe you can do something like this in your head, but I'd like to see your work because a lot can go wrong in these problems, and I'd like to give you partial credit somewhere. Sorry, I'm just making sure I'm not running low on time. Plenty of time. 2z times 3z. Remember, multiply the coefficients. So 2 times 3 is 6, and add their exponents. Z times z is z squared. Just like x times x is x squared. 1 plus 1 is 2. Alrighty. Plus 2z times -3. 2 times -3 is -6. And then the z just comes along for the ride. There's nothing for that to get multiplied by. Plus 4 times 3z. 4 times 3 is 12. And then the z just gets added on as well. And then plus 4 times -3, which is -12. All right, you must clean this up as much as it will go. So whenever you do FOIL method, the middle two terms should always cancel, or not cancel, I'm sorry. They should always clean up though. You should always clean this up. If you left it like this, you would lose half a point. This isn't cleaned enough. All right, so 6z squared is cleaned up plenty. But this -6z and +12z, those are like terms. They both have just one z, so I can take -6 and add 12. -6 plus 12 is +6. Again, if you're never not sure, please use your calculator. So those cancel, or those don't cancel, but they simplify, and then -12. Now that is cleaned up. Nothing else can simplify. Okay, any questions from my friends? Alrighty, one last one. This one definitely needs work. This one we're still gonna follow FOIL just because it has three things doesn't make it any more difficult. It does add a little bit more work and makes it a little bit more of a longer problem, but follow FOIL. FOIL works every time. Use the arrows. I always need to if this was a Go formative and you couldn't write on this problem, I would rewrite it just so you can use the arrows. So I'm going to draw my arrows. I'm going to take 9x and multiply it by absolutely everything. So 9x gets multiplied by the first term, the middle term, and the last term. And then same thing with the -8. The first term, the middle term, and the last term. Then I'm just going to follow my arrows. Write down everything your arrows tell you to do. So I'm going to move this over and start a little bit more to the left. I'm going to follow my very first arrow, which was 9x times -3x squared. So 9x times -3x squared. Okay, again, you have to show me this step because a lot can go wrong. All right, now follow then plus 9x, follow my second arrow. It went to the middle term, so 9x times -3x. Okay. Then following my last arrow, plus 9x times 8. Alrighty, then I'm done with my 9x. Now I'm going to mess with this -8. So that's a -8, so I'm going to do -8 because that's a -8. So -8 times -3x squared. I'm going to zoom out a little bit more. Let me cross. This is where the problem is. Then I'm going to do -8 times the middle term, which is -3x. And then my last term, which is -8 times +8. Okay. Now, I'm just going to clean it up. There's a lot of work to the cleanup, so please make sure you pay attention here. Remember, this 9x has an exponent of 1, so I'm going to multiply their coefficients. 9 times -3 is -27x, and then x to the first power times x to the second. I'm going to add their coefficients to get x to the third power. Okay, plus 9 again times -3. Well, that's -27 again. So I'm going to erase this plus sign. I wrote the plus sign because I saw it, but I know that I'm going to have a -27. So I'm just going to erase that plus sign and keep it -27 again. 9 times -3 is -27. And then again, you know this, x times x is x squared. And if you don't notice that, write in their exponents. Add the exponents always. All right, and then plus 9x times 8. 9 times 8 is 72. And then just that x comes along for the ride. All righty, then -8 times -3 is a +24. And then x squared just comes along for the ride because I have no x to compare it with. Then -8 times -3x, this is where I'm at in case you lost me. -8 times -3x is +24x. And then -8 times 8 is -64. All right, any questions so far? We're almost done. Could I leave my problem like this? Could I be like, okay, well, I multiplied them as Bishop. I'm good. Why can I not leave my problem like that? In the chat, why could I not leave it like that? Why is that kind of cringeworthy? Yeah, there are still like terms. This could be cleaned up a little bit. Usually your first term won't clean up. So I'm going to look and search this thing. It doesn't look like there's anything I can compare the x third with because there's nothing else with x to the third power. So if nothing cleans up with it, you just bring it back down. So -27 x to the third power. That didn't clean up with anything, so I'm just going to cross it out. Negative 27x squared has a like term with 24x squared because they both are x squared. Negative 20, so then you add their coefficients. Negative 27 plus 24 is just negative 3, and then x squared. I'm going to move this down so I'm not writing on that page, just so we're not confused. So negative 27x to the third minus 3x squared. Again, if you need your calculator, please use it. Don't make the silly mistakes. Alrighty. 72x combines with 24x because they both have like terms of just x. 72 plus 24 is 96x. Let's cross those out, and then that just leaves the 64 at the end. All right, I hope you believe me and think that I'm reasonable for saying there's no way I could have gone from here to the answer without showing any work. Okay. Any questions? All right, then